Hey guys, welcome back to the laboratory. In this video, we are looking at acids. By the end of this video, you should be able to describe the difference between concentrated and dilute solutions, explain how the pH of an acid changes as the concentration of hydrogen ions change, and explain the difference between strong and weak acids. So, let's go. The concentration of a substance is a measure of how much solute there is per unit volume of a solution. A solute is a solid that can be dissolved into a solvent. A solution is the mixture formed when the solute dissolves into the solvent. In a fixed volume, the concentration of a solution will increase as the concentration of solute increases too. For example, both of these beakers contain an equal volume of water. However, this beaker contains a more concentrated solution, as there is a larger amount of dissolved solute particles, in comparison to this beaker, which contains fewer dissolved solute particles, therefore forming a more dilute solution. We can calculate the concentration of a solution using this simple formula, where concentration is equal to the amount of dissolved solute divided by the volume of the solution. The units used for concentration are grams per decimeter cubed. For example, 2.3 grams of sodium chloride is dissolved in water to make 2 decimeter cubed of sodium chloride solution. Calculate the concentration of the solution. There is 2.3 grams of dissolved solute in 2 decimeter cubed of solution. Therefore, the calculation for this question is 2.3 divided by 2. The concentration of this solution is 1.15 grams per decimeter cubed. In some questions, the volume of the solution may be given to you in centimeter cubed. To convert this unit into decimeter cubed, you must divide the value by 1000. For example, 0.5 grams of potassium bromide is dissolved in water to make 250 centimeter cubed of potassium bromide solution. Calculate the concentration of the solution. As the volume of the solution has been given in centimeter cubed, we must divide it by 1000 to ensure that our answer is in the correct units. 250 divided by 1000 is 0.25. Now that we have converted our units, we can complete the calculation as usual. 0.5 divided by 0.25 is equal to 2. The concentration of this solution is 2 grams per decimeter cubed. The concentration of hydrogen ions in an acid is directly linked to its pH. When the concentration of hydrogen ions is increased by a factor of 10, the pH of the acid will decrease by 1, therefore becoming a stronger acid. However, when the concentration of hydrogen ions is decreased by a factor of 10, the pH of the acid will increase by 1, therefore becoming less acidic. For example, vinegar has a pH of 3. Lemon juice with a pH of 2 will contain 10 times more hydrogen ions than vinegar, and stomach acid with a pH of 1 will contain 10 times 10 more hydrogen ions than vinegar. However, tomato juice with a pH of 4 will contain 10 times less hydrogen ions than vinegar, and coffee with a pH of 5 will contain 10 times 10 less hydrogen ions than vinegar. As well as the concentration of hydrogen ions it contains, the strength of an acid is also determined by how readily it dissociates or splits into its respective ions. Strong acids completely dissociate into ions, releasing large numbers of hydrogen ions into solution, whereas weak acids only partially dissociate into ions, releasing smaller numbers of hydrogen ions into solution. This means that the pH value of a stronger acid is much lower than the pH value of a weaker acid. For example, a strong acid, like hydrochloric acid, will completely dissociate into its respective ions, releasing large numbers of hydrogen ions in solution. This explains why hydrochloric acid has a pH of 1. In contrast, a weaker acid, such as ethanoic acid, will only partially dissociate into its respective ions, releasing smaller numbers of hydrogen ions into solution. This explains why ethanoic acid has a pH of 3. The concentration of an acid is not to be confused with the strength of an acid. The concentration of an acid is a measure of how much acid molecules there are per unit volume of a solution, whilst the strength of an acid is a measure of how much those acid molecules will dissociate into its ions. For example, a solution of a concentrated weak acid would contain a high number of acid molecules. However, only a few of those molecules would have dissociated into ions, whereas a solution of a concentrated strong acid would also contain a high number of acid molecules, where all acid molecules will have dissociated into ions. In contrast, a solution of a dilute weak acid would contain smaller numbers of acid molecules, where only a few of those molecules have dissociated into ions, whereas a solution of a dilute strong acid would contain small numbers of acid molecules, where all molecules have dissociated into ions. Here's an example of a past paper question that you can attempt to test your understanding of the concepts covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. This question states that solution X has a pH of 3.40 and solution Y has a pH of 4.40. You are asked to identify how the concentration of hydrogen ions in solution X compare with the concentration of hydrogen ions in solution Y. We can see that both solutions differ by a value of 1. This automatically indicates to us that the concentration of hydrogen ions in both solutions must differ by a factor of 10, and so this eliminates options B and C automatically. Solution X has a lower pH than solution Y, therefore solution X is the stronger acid of the two. The strength of the acid increases as the number of hydrogen ions increase, therefore solution X must have more hydrogen ions than solution Y. The concentration of hydrogen ions in solution X must be 10 times more the concentration of hydrogen ions in solution Y, as they differ by a value of 1. The correct answer to this question is option D. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!